Welcome to the video lecture on designing physical files. So let's talk about this for a second. Physical files are literally files that you're going to have out on disk, right? So, for instance, on my Mac, I look at a folder and I literally have files. Like these are, I have some PowerPoint files, I've got some, some Word files, I've got some picture files, right? So I've got all sorts of files. So when I talk about a physical file, that's exactly what I'm talking about. Simply a physical file that's going to be out there on disk, right? So when I'm designing my physical files, I'm telling the database management system to work with the operating system and set up the physical files. So when I set up a physical file, it is a named portion of secondary memory allocated for the memory of storing physical records. So for instance, when I set up this file takes up 1.2 megabytes of disk space. The operating system is handling that. All right, so when I save this file, and I tell the operating system where to save the file, the operating system is keeping track of where the file is and how much disk space it's taking up. All right, it will get fragmented if in contiguous memory, right? Hard disk space. So if it's not contiguous, it becomes fragmented, and I would have to go through a defragmenting to put these files together. So what do I mean by that? So let's look at, where's my paintbrush? So here we are again. If you haven't seen this before, here it is again. So this figure is representing a hard disk. Okay, so on the hard disk, I will allocate, say, a whole section of data, right? So a whole section of this will be allocated to a file, right? So I tell the operating system through the database management system, I need a file and I need it to be this big, and it allocates space on disk. Now, of course, it could be enormous. I mean, I could take up multiple disks worth of space. It can get pretty ugly. All right, so I'll get rid of that. So I've got this space allocated. And let's just say, for instance, I'm going to allocate, this is getting ugly. I'm going to allocate these sectors to a particular file. And I'm going to tell the database management system this is a file that I'm going to use. So the operating system knows that I'm going to use this for my storage. So I'm going to give it a name, all right, and whatever the name is, use some kind of good naming convention. And then what I'm going to do is I'm going to set up a table space. A table space is a name set of disk storage elements in which physical files for database tables can be stored. So now I'm going to set up a larger parent to that. So now this was a particular file. Now I'm going to say this is the table space. All right, so this whole disk is going to be a table space, and within that table space, I am storing a file. I can actually store, 6 or 7 files. So I'm going to store another little file on this track or this sector, and so on. Right, so I'm going to put another file. Will take up these 2 sectors. All right. So that's what we're talking about. So I've got a table space. I'm going to tell the database management system to work with the operating system, set up a table space. That table space will have the name files within it, and then after that we get down to extents. We talked about blocks previously. Now we're going to talk about extents. Extents is the term more often used when you're talking about something like Oracle or any database management system, really. So it's a contiguous section of disk space. What is that? That would be, let me get rid of this, or these. So when I'm writing a record, this is contiguous. And then if I need, if that record gets extended, right, so I'm going to write another record here. I'm going to write another record here so you can kind of see the separation. Another record here. I'm going to keep going along writing my records, la-da-dee-dee-dum, and this is all in a file that is in a table space. Right, so I'm writing these all. As time goes on, I'm going to be making updates, right? Maybe these were inserts. Well, eventually I'm going to be making updates. Now these updates may take up more space than this, but they can't be put here because this space is already filled, right? I've got these records are one right after the other. So when I make additions to a record, that record may not be able to store, is not going to be able to store it in the same contiguous bit of disk space. So I may need to store a bit of it over here, and then a bit of it over here, and then a bit of it over here. And what happens is, in order for that, I have to then link two pieces of data. So first of all, an extent would be a bunch of contiguous pieces of disk space. So it could have, this could be an extent. Sorry, I'm not drawing very well. So all this is an extent. Within that, I have a bunch of records, as I have in this sector, right? So I've got a bunch of extents. They all have any number of records, again, depending on your record size and the size of the extent, right? So then what happens is I'm going to have to link them together. So now I have to link two pieces of data together. So I can either do sequential storage, right, which is, for all intents and purposes, this, just continually adding records, right, in a sequential manner. And this way, when I need to tell the database, hey, go find something, it's going to go sequentially searching through this whole section to try to find the data that I'm looking for. It's going to go record by record by record looking. Or we can use what are known as pointers. And pointers is a field of data that can be used to locate related fields or records. So I can have, for instance, I have all my records in this, right? And then what I do over here is I have a list of key values. And then those key values point to, oh, that's where that record starts. That's where that record starts. That's where that record starts. All right? Pointers are also used when I have fragments of data in other areas. So this record has to point to this because that's where that record continues in a different extent. Okay, so physical disk storage gets very, very complicated. But I hope that those little diagrams, as ugly as they were, may have helped you with that. So we're going to talk more about sequential storage and pointers and the different file organizations in another video lecture. But that's the end of Designing Physical Files.